Thank you, Fiona. Welcome, everyone. So, I've been given 6 minutes to talk about performance. So, I'll try to make it a high performance talk, right? Uh, so, let's get straight into it. So, we build these awesome applications, and then time to time, we find out that, okay, they're not up to our expectations performance wise. So, when you hit these problems, to handle these situations, I think I will always follow three key things. Okay. So first thing is it's important not to assume anything about a performance problem. Okay. The next one is you have to understand when you're building web application what kind of problems you are dealing with and what kind of tools you have in your toolbox to identify these problems. Right. And then once you know this stuff, then the only thing that will take you to a conclusion with the performance problem is measuring. So you measure all the components in your system until you find out where the bottleneck is. Okay. So the first things first, let's go have a look at who are your enemies, right? So when we build web applications, we're finally dealing with three enemies, right? So we're dealing with latency related issues, right? So network is your biggest enemy. This you saw in one of the presentations that how they improve performance by reducing number of images. And then one of the other things is the complexity of your own application. So you write this brilliant JavaScript, and then all of a sudden you find out that the algorithm is probably not the best algorithm you can come up with. So the complexity. And then the third one is probably the most interesting one for you, the rendering. So you have to battle with the rendering engines in various different browsers. All right. So how do you work with these enemies? Let's go through rendering first because I thought I've been given only 6 minutes. So I probably won't have time to cover all the things. I thought I'd cover rendering for CSS and HTML devs. Okay, so that's important to understand because if you know how that works, then you could be a rock star, right? So so rendering is a really complex process. What that means is you got your HTML and CSS and probably a little bit of JavaScript, and you hand it over to a browser, and it does some complex task of putting that thing into a pretty picture on the screen. Okay, so this process is fairly complex, but all the modern browsers they have sort of broken it down into 4 primary steps. Okay, so if you understand those 4 primary steps, you could easily detect where your bottlenecks are. Okay, so the first step it does is it looks at your HTML and CSS, and it sort of figures out okay what your styles are and how they should be applied to your elements. Okay, so once they know that, they change your DOM tree structure into a different structure, what they call a layer structure, render structure, right? And during that process, it sort of figures out what size your elements should be and where the position of those elements are. Okay, so they also call it, the browser vendors normally call that one the geometry of your page. Okay, so it figures out the geometry of the page. Once the geometry is known, what they do is they take all of your elements and then turns them into pixels and then paint them on blocks of images on what they call a layer. Okay, so you can have at minimum you have at least one layer on every page, but you could have multiple layers depending on what markup you have, right? So once they have all these layers, so elements painted on layers, they set it all the way to oops, I lost my sorry, this okay, so sorry, that's my bad. Okay, so it sends these layers to your GPU. Okay, and then GPU does the work of printing those pixels on your screen, right? So it's important to understand what kind of things you do in CSS and JavaScript can cause any one of these stages in the rendering engine. Because not all the things you do will cause everything to happen. Okay, so obviously during the first page load, all of these things will happen at least once. But then after that, it depends on what you do, what browser does. Say for instance, if you change the position of your element, okay, then what you're doing is under the powers, you're changing the geometry of it. Okay, so what the browser has to do, it has to actually go to it has to calculate the start, and then it starts to work all the way from the top layer, and then paint, and then composite layers. So it has to do all four things. So position is one of the bad things that you can change in an animation, for instance, because it could, like if you're doing that for longer time, then it could really impact your performance, right? And then paint. Paint is something like if you change a background color of an element, for instance, right? It's not going to the browser doesn't have to calculate the geometry again because it already you have changed the position on the site, so it can start from the paint step and then work all the way down. So it's kind of less expensive than changing the position, right? And then there are certain operations you can do in with your elements, like changing the opacity, for instance. If you do that, then the browser doesn't even have to do painting because it's done the painting already, and it can just simply tell the GPU, hey, just change the opacity, and it'll be like the fastest, right? So this doesn't mean that you can't use these things in your CSS anymore, because that'll be the wrong message to get out of this talk, right? So you can go crazy, right? Do all these things to give the best user experience that your users want. But what you need to know is when it hits the fan, right? You have to go and figure out where this is. So how to figure it out is right there in Chrome DevTools, okay? So you could just open Chrome DevTools and go to timeline and then start record button, and then you could just go through, like, perform your actions. And after that, when you monitor the timeline waterfall view, you can understand what your application is doing. Okay, and if you know these steps, you can sort of easily figure out, okay, I know where my problem is, and this JavaScript is changing this bit, and therefore it triggers these things. Okay, so today I can't really give you a demo of that because we're limited with time. But if you're interested, you could just flick a message to David, and in a future session, I could do a deep dive session. It would probably take about 40 minutes, and we can just cover the whole drill end to end with live demos. Okay, so just touching quickly on the rest of the slides. Network latency, again, it's caused by stuff like the bandwidth. So you obviously have to fight with different network speeds, right? So when you build responsive applications, your app could be used by someone who's on a 3G network, right? So that sort of stuff you don't have to have devices or be on these networks to simulate them. Chrome DevTools comes with network throttling features, so you can use them to simulate and see how your app behaves when you don't have enough internet speed. And also, when it comes to downloading resources, you know it's a good practice to distribute your resources across multiple servers. But then one of the other problems that come with that is the DNS resolution, because when browser wants to download something, it doesn't necessarily know where it is straight away. So it has to do one step to figure out where the server is. So sometimes, because of the problems or the infrastructure related issues, you might have DNS resolution problems causing your site to appear slow, right? And then when you have concurrent connections, it can easily overload your server. Also missing optimizations, like sometimes you do minification and concatenation of CSS, JavaScript, but you forget to turn on the compression on your web server, right? All of a sudden your payload is still probably 10 times larger than what it should be. So to identify these things, again, you can use Chrome DevTools. It comes with a really nice network tab, and it shows you in waterfall view of what you get, and then it sort of gives you breakdown figures of how much time it's spending on waiting before the request, and how much time it spends on DNS resolution, and how much time it spends on waiting to receive the first byte from the server, and then how much time on actually receiving the content, right? Again, so on that note, about the response from the server, it's really important to understand sometimes your application could be slow because the servers are genuinely slow because of the application logic in the backend. To detect this sort of stuff, you could actually go to Chrome DevTools. One of the things that I'm looking at is for this particular scenario is a figure called time to first byte, TTFB, right? So if you see TTFB is taking a lot longer, that means you have a problem somewhere in your server or something in between your browser and your server, right? So you got to keep an eye on that, right? because you can't blame on your bandwidth speed in those areas. And then finally, script complexity. So this is again, like I said, your code could be really complex, and you need to identify where the complexity is. Again, in Chrome DevTools, there is a tab called Profiler, and you run Profiler, and you can find out where exactly your bottlenecks are. Say, for instance, it could tell you, okay, this script is taking this amount of time before we can show something, right? So, and so that's just a brief introduction or a very key points around what you can do to identify these things. So if you know them, you can definitely dive into Chrome DevTools and start looking at the real clues, the real facts around what your problem is. So once you know that, it's very easy to fix. So hope you have better luck with the next performance analysis with these tips. Thank you very much.